Welcome back to the A4Q Testing Summit. With me today, I have Dr. Abbas AHMAD. He is the co-founder of Certilog FZCO based in Dubai, and he is also the president of the UAESTQB. Today, he's going to be sharing some valuable insights about model-based testing. I hand over to you.
Thank you, Abby. Do you hear me well?
All good on our side. You're good to go. Thank you.
Thank you. Thank you, Abby. Thank you for being here. Today, we are going to speak about model-based testing. We are going to discover what is model-based testing. First, let's have an introduction about model-based testing in general. And I was a bit curious about how an AI would illustrate model-based testing. So that's the first thing that I did in order to prepare this presentation. I asked an AI to illustrate to me what is model-based testing. Can it represent it for me to show you? And this is the result. And I can safely say that no. So there is no model-based testers in this image, and there is no model-based testing going on here in this representation. Well, this was done with one of the AI illustrators available on the market. So on a more serious note, model-based testing is a testing approach. And if you're still wondering what is a testing approach, maybe you are more familiar with the usual testing approaches. For example, you all know the manual testing approach, the automated testing approach. And I hope that we can safely say that the automated testing is an evolution of manual testing. So let me be clear here. We are not saying that if you automate your tests, you are not going to need any more manual testing. We are just saying that it is an evolution. You can do things faster in a more precise way, a more reliable way. You will have more time to do exploratory testing. So we are not going to fire all of our manual testers when we automate our tests, but we will give them more time to do some exploratory testing, to do some reviews. There will be freedom. So the question is that I want you to remember is, where do we place model-based testing approach in this presentation? Is it an evolution of automated testing? Is it better? Is it more reliable than those approaches? So, in order to respond to this question, we will come back to this question at the end of the presentation. Let's see first and foremost what is a model. When we are speaking about model-based testing models, yes, it is the title is correct. We speak about an MBT model because remember, model-based testing is the approach, and the model of this approach is just one of the work products. So we can call it, so you will see I will sometimes mix the terms, or sometimes call it the MBT model or just model to refer to the work product. And if you are still wondering what is a work product, what exactly is a work product? So in manual testing, you have the test cases to be executed manually, which are a work product, one of the main work products of manual testing. In automated testing, you will produce test scripts for automated execution. And in model-based testing, you will produce models, and we call it so the MBT model. So precisely what is a model? What does it do? When we are speaking about model-based testing, what is the work product of model? This is the heart of the approach, is to produce the model. This is from everything that you do before and after. And if you're asking what is before a model and what is after a model, we will see it together. But first of all, let's define what is a model. A model is a partial description of a system under test, so we refer to it as SUT. And we talk about abstraction. So we say partial description because nowadays the system under test, the systems that you are testing. So I'm not speaking about software under test. You have to be careful. We speak about system. It can be just software. It can be hardware and software. It can be a system standalone. It can be a system of systems. It can be anything. But we are speaking about making an abstraction of this system in order to represent its behavior. We want to represent the behavior of the system we are testing in order to generate test cases. So the model is used for test case generation. We don't have execution of tests because we don't have tests from the model. We have generation of test cases in order to implement them first. And remember, we spoke about the model being a partial description. It's an abstraction of the system under test that you are going to represent. So you are going to produce most of the time abstract test cases which need to be implemented. When you implement that, you have executable tests, which are obviously executed. And in general, you have two general model representations. You have the textual model and a visual one. So for one example of textual model is this slide that you are seeing on the screen right now. It is a model of an MBT model in a textual form. So I made an abstraction, a really gross one. In fact, I'm not saying that I did a good job here, but it is a textual model of an MBT model, explaining. I made an abstraction of everything. And you have the visual one, which I can give you an example right now. And you can see everything that is in the slide. So the model is a partial description of ASUT, a system under test. You have abstract test cases which are derived from the model. When we implement them, we have executable tests. So the executable tests are an implementation of abstract tests, and they are run against the system under test. For me, I think that, well, the visual models are more communicative. It is much easier in general for us, to understand something which is visual. We can find the bottlenecks and every problem that we have in our description much easier in a visual model. Remember when I said that the model is a work product of the MBT, same as test cases are a work product of manual testing, and test scripts are a work product of automated testing. Well, let's take the example of automated testing. When you have test scripts, they are going to be written in a language. For example, you can write in Java, you can write in Python, you can write in robot framework, you can write in any language. It's the same for the models. We have languages in order to write our models, and there are two languages which are proposed by the UAESTQB. No worries, we're not going into all the details. This is not a technical presentation. We are going to stay abstract. But this is just for you to have a representation of what are the workflows, what are the languages available. Both of the languages, the workflow based where we go going to represent the behavior of the system under test for testing, or the state transition-based modeling language, where we're going to represent the states of our system. They are both just a subset of the unified modeling language, UML. We take the whole UML, and we can take a subset of it, and you have those languages available to us. So there are a lot more of languages to make visual models. So this was the presentation of MBT models in general. So let's go a little bit deeper. So we saw the gift box from the outside. Now let's open the gift box and see what's on the inside in a little bit more details. First of all, let's check the fundamental MBT process. So this part is to present to you. So if you want to apply model-based testing, what do I have to do exactly? What is the process? What I am doing when I'm testing with an MBT approach? First of all, it starts like all the approaches. Basically, we are going to have some test basis, to have the requirements, the specification, and we can derive user stories from them. We can have user story directly, depends on your test basis, but you are going to start with a set of requirements, which you will derive test objectives. So in order to represent the system under test in a model. And remember when I said that the model is here to generate test cases. So you will generate test cases with your model. But a good practice is to have some sort of selection criteria to your tests. Why do we want to apply some selection criteria to our test? Is to avoid test case explosion. So this is the definition of the ISTQB glossary. Is the disproportionate growth of the number of test cases. The test selection criteria is really important because we don't want to have an unlimited number of test cases, and we want to restrain our test case generation to some criteria that we are going to choose. I give you some examples. For example, it can be coverage-based. This is the most common criteria used in model-based testing. For example, it can be coverage of your requirements. It can be random-based. It can be scenario-based. It can be based on some characteristics of your project. For example, if it is a critical project, we want to cover all the high-level risks in the project. It depends on your context. So this is one of the 7 principles of testing. Testing is context dependent and can be taken into account in the model-based testing approach. So when we are ready to generate our test cases, we have a set of model-based testing tests, and we want to execute them. So we can execute them in different ways. For example, we can have them in form of test cases for manual execution, and we can have them also in form of automated test scripts for automated execution. There are some specific details that need to be added depending on are we doing test cases. So for example, for manual execution, it does not make sense to go into all the details of your test cases. For example, if I give you an example of testing an e-commerce website, you can have your test case, which is I log in with valid credentials, I add an item to my cart, and I check out successfully. This is enough for manual execution make a test. But for automated test execution, you will need to implement. It will be high-level representation. Remember, we are doing an abstraction of the system under test. We will need to add details to our model in order to have test scripts. So depending on the tool, depending on the knowledge of the testers, you can have any of those exportables published for execution. So let's go back to our fundamental process. You have your test. The testers will use the test scripts or test cases in order to execute the tests on the system under test. So who does the system under test? It's the developers, thankfully. And we will execute those tests in order to have a result. That's basically the fundamental MBT process, really simplified. From far, it looks like this. You have certain processes which can be, you can add some steps, remove some steps, but generally, globally, this is the fundamental model-based testing process. The core of the MBT approach, the model-based testing approach, its core is test analysis and design. This is the core of the model-based testing approach, is analyzing and designing the test cases. It is the main objective of model-based testing. It is to generate automatically test cases. So why do I want to do model-based testing? What are the benefits of doing model-based testing? So let's go through some of the benefits. So we will not do them all. You can see it's an infinite number of benefits. This is a biased number, but let's delve into some of the benefits and see what are the challenges of model-based testing. First of the benefits is it's in its core you have bidirectional traceability. So if you ask me what is a traceability first before going into the bidirectional one, the traceability is to be able to follow, for example, metrics of coverage. This is one of the example. For example, I want to know which of my requirements are covered by test cases. With that traceability, I can follow, okay, this requirement is covered by this test script, by this test result, by this test objective. This is in one way. And to have a bidirectional traceability is to be able to go on the other way. For example, taking a test result and saying, okay, this test result is covering this requirement. So in the end, we can have, for example, check how many test fails are attributed to one requirement and how many test passes, test success are attributed to one requirement, to one test case in both ways. It depends a lot if the model-based testing tool you are using is able to handle the traceability, of course, but most of them understand that it is a priority in model-based testing, and most of the model-based testing tools that you have out there on the market will integrate ways for you to maintain this bidirectional traceability. And it is really important also down the line to make the maintenance better of your test cases. We will speak about that in just a few. Some other benefits, it's you have better communication in your team between your developer, your tester, your clients, your product owner. With a visual model, it's like a living documentation. You will be able to see if the client requirements were properly expressed. He will be able to tell you, okay, this is the correct behavior of my the application that I want to build. And as a matter of fact, the MBT, the model-based testing approach, is a shift-left enabler. With, for example, one of the examples is acceptance test-driven development, where the shift-left approach is where we are going to have much more attention to quality at the start of the software development life cycle. And we are going to have less maintenance on our product at the end. Other benefits is that the model-based testing covers a lot of test levels. So we have the 4 test levels, which are acceptance testing, and this is one of the best level to test with model-based testing. You have also system and integration levels, which are good, which are really useful. For component testing, it is a bit more difficult. It's not impossible. So you have class diagrams which can be used depending on the tool. It's a bit more complicated, but it's not impossible. So depending on the context of your project, it can be done. Then for some of the test types, obviously functional tests is the way to go for model-based testing. And for non-functional tests, for example, for testing some security aspects, performance aspects, it can be done, but depending again on your project context. It has to be studied, and we will see a little bit later in the conclusion how we can study if model-based testing is the solution I want to pick. One of the last benefits I want to go through with you today is the highly adaptable nature of model-based testing to any software development lifecycle. It is highly adaptable to agile. It can be used in more sequential software development lifecycle like waterfall and other. But here you have a representation of a typical Scrum life cycle or sprint. You have the product backlog, and it will you have the sprints, which is usually from 2 to 4 weeks. It can be more, it can be less. But if you are using MBT, it is highly adaptable. Why? Because you don't have to start the model for every sprint. You are just adding. You are making an evolution of your model. You are going to augment its SUT representation on every sprint, and the model will grow alongside your project. So for the challenges, we have no challenges. No, just kidding. We have some challenges in model-based testing, so that was not really true. Some of the misconceptions around model-based testing, the approach is saying that model-based testing will solve every problem. So of course not. MBT does not replace competent testers. You need to train your tester to modeling or using the tools. Just saying this is for our second point, that MBT is just a tooling issue. I want to do model-based testing in my project, so I will just buy a tool and I'm fine and can keep everything that I was doing before the same. So that's also not true. Model-based testing will impact your entire testing process. It is adaptable, highly adaptable to your process, but it will have an impact in all the test activities, going from planning to design, analysis, implementation, execution. It has an impact on all those testing activities. So this is something that you have to keep in mind when you want to consider model-based testing. Other thing is saying that the models are always correct. So this is one of the biggest erroneous expectation. The model has no intention of being done by one tester or one single group of testers. It must always be validated and verified from the business side, for all the people who are involved in the project. It is a good practice to review the model in order to ensure that everything is designed correctly. And of course, one of the big challenges is the explosion in the number of test cases. So it must be mastered by following the MBD best practices in test selection criteria. So I think that said, this is something between a challenge and a benefit. Depends to who you ask. Depends on your point of view. So when I'm saying that model-based testing is not a short-term investment, what I mean by that is it costs, the entry barrier is really high to model-based testing. It doesn't have to be, but it usually is, because it is not something which is widely spread. So you have the cost. The initial costs are the tools licenses. You don't have a lot of open source model-based modeling tools. The tools have licenses in most cases. The resource training, so you will need to train your tester to modeling. You will have also to model, to produce the model for your system under test. This is all highly, it costs a lot at the start of your project. But what you have at the start of the project is long-term vision. So you will have way less maintenance down the line in the mid-term, long-term vision, where you will see a reduction in maintenance cost. You will see higher levels of efficiency, quality, and speed. So you will have to balance all of this. So if your goal is to have 400 tests within 1 month, because we are late at testing our application, maybe MBT is not for you. So it will depend on your context, but you have to see it as a mid to long-term investment, depending on your project. In order to conclude our presentation, I want to go back to the question that I was asking you at the start of the presentation. Is MBT, is model-based testing an evolution from manual testing, automated testing? So model-based testing is like upgrading from paper maps to GPS. So it's smarter, faster, and more reliable. For me, it is an evolution. It costs a lot. Yes, in order to have GPS, you have to launch the satellites into orbit. You have to develop the software for the maps. You have to design the maps. But it's definitely an evolution. I know some people say I prefer maps, so this is just my opinion. And I invite you to try model-based testing, to have your own opinion on it. So the classic product adoption process, you have it represented here. It goes from knowing that we have a problem. So if you have never heard about model-based testing, you are at the first step, and the thing that you will have is like, okay, I have a problem that MBT can solve, whether it be we have a lot of maintenance on our test, and maybe the model MBT approach can help us lower the cost of those tests. our requirements are changing a lot. Maybe model-based testing can help us lowering the cost of changing a requirement. So it depends. Second step is knowledge. So you're going to train, you're going to see, okay, what can I do with model-based testing? You're going to evaluate it in your own context. And the last part are doing a proof of concepts, defining some KPIs, and at the end is to adopt it. Of course, remember, the important things is to define your objectives. What are the objectives of your approach? Estimate the return on investment. So this is the work for the test managers, for you as testers. You can also help them get all the metrics to estimate the return on investment. And thank you for being here. And do you have any questions for me?
First off, I'd like to say thank you so much for such a well-rounded understanding about incorporating model-based testing into testing strategies. We do have some questions here for you. Could you explain a bit more about how to handle model complexity? Do you have any practical tips for simplifying complex models?
Yes, thank you. Thank you for this interesting questions, because I spoke about the complex nature of the systems that we are testing today. It's usually a system of systems, and representing the behavior of those systems can produce really complex models. And it's like any language. So depending on the MBT language that you're going to use, you can have sub-models, for example, in a bigger model. So you can have some sort of fragmentation into smaller pieces to your model. That's one of the biggest tips for handling complexity. It's to cut your big problem into smaller problem in order to understand it much easier.
Okay, thank you so much. The next question is, actually, you mentioned the importance of accurate models. How do we ensure the models remain accurate as the software evolves?
Totally. One of the most important things is to have models that represent effectively the software. And the best way to ensure that the model remains accurate is to communicate some more. Do not think that even if you have years of modeling experience, do not say, okay, this model is the correct one and it should do the job. No, go and validate it with the business side, the developer side, and just communication is the key point here. In order to, it's a living documentation, so take advantage of that. It is easy to understand, it is easy to validate. That's the way to go.
Thank you so much. I think this will be our very last question for our session. For those considering adopting model-based testing, what would you say are the first steps to get started?
I think one of the first steps is that being present here, listening, for example, a session about model-based testing is to have conscience. What is the problem? The second step is go see what are the tools. So you have to evaluate, you have to test a little bit. You can check some open source tools, but don't hesitate to talk to tool providers, MBT tools providers. Send them an email. Usually they have a contact form. They will be more than happy to show you the capabilities of their tools. They will even some of the times give you some free licenses for the tool. in order for you to test, play around with it, and see how if it is the right fit for your project. So don't hesitate to speak with tool providers. So we'll be more than happy to show you the benefits of the MBT.
Wonderful. Thank you so much. And to all of our viewers watching today, stay tuned. We have more sessions today about a variety of topics. Follow us on social media and check out our YouTube channel. Thank you so much. Thank you, Dr. Abbas AHMAD.
Thank you.